Hello everyone, my name is S. Vijay Kumari. I am studying second year MPCS. Now I am going to explain about an important theorem. The union of any two subgroups of a group G comma dot is a subgroup of G if and only if contained in the other. Or if H1 and H2 are any two subgroups of a group G comma dot, then H1 union H2 is a subgroup of G if and only if H1 subset H2 or H2 subset H1. Proof: H1 and H2 be two subgroups of a group G comma dot. Claim: H1 union H2 is a subgroup of G if and only if H1 subset of H2 or H2 subset of H1. Suppose H1 union H2 is a subgroup of G. We have to prove that H1 subset of H2 or H2 subset of H1. Let H1 subset of H2 and H2 not subset of H1. Therefore, H1 not subset H2, then there exists A belongs to H1 such that A does not belongs to H2. Therefore, H2 not subset of H1. Therefore, then there exists B belongs to H2 such that B does not belongs to H1. Therefore, A belongs to H1. A belongs to H1 union H2. B belongs to H2. B belongs to H1 union H2. Therefore, A comma B H1 union H2, AB belongs to H1 union H2. Here H1 union H2 is a subgroup. AB belongs to H1 or AB belongs to H2. Suppose AB belongs to H1, therefore A belongs to H1 and AB belongs to H1. This implies A inverse B belongs to H1. Here H1 is a subgroup. A inverse A into B belongs to H1. E into B belongs to H1. B belongs to H1, which is a contradiction. B does not belongs to H1. AB does not belongs to H1. Suppose AB belongs to H2, AB belongs to H2 and B belongs to H2. AB into B inverse belongs to H2. Here H2 is a subgroup. A B into B inverse belongs to H2 and A into E belongs to H2. A belongs to H2, which is a contradiction. Therefore, A does not belongs to H2. Therefore, AB does not belongs to H2. AB belongs to H1. H1 union H2. AB does not belongs to H1 and AB does not belongs to H2, which is a contradiction. Therefore, our supposition is wrong. Therefore, H1 subset of H2 or H2 subset of H1. Second, conversely, suppose H1 union H1 subset of H2 or H2 subset of H1. If H1 subset of H2, then H1 union H2 equal to H2, which is a subgroup of G. If H2 subset of H1, then H1 union H2 equal to H1, which is a subgroup of G. Hence, H1 union H2 is a subgroup of G if and only if H1 subset of H2 or H2 subset of H1, hence proved.